Development Process Using AI with Ryan Riley.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. I have a return guest on the show with me today, Ryan Riley, back from episode 316 was the most recent episode. Ryan is a senior lead software engineer at Quorum Software in Houston, Texas. He has deep expertise in functional programming, software architecture, web API design, across so many technologies in the .NET ecosystem. He's a Microsoft Visual F# MVP award winner and a longtime open source contributor. He's best known for his work on projects such as Frank and WebApiContrib and Open Web Interface for .NET. That's OWIN, the specification for that. And he also leads the community for F# virtual user group and is an active blogger. He's recently published quite a few thought-provoking pieces examining AI-assisted spec-driven development and other things. And he brings a thoughtful system-level perspective to software engineering leadership, mentoring, and team building. And he covers from front-end UX all the way through back-end and distributed applications. And he has over 2 decades of experience in the software industry. Ryan, welcome back to the show. How are you, sir?
I'm doing well. Thank you, Jeffrey. It's nice to be back. Nice to see you again.
Absolutely. Absolutely. You know, you and I have known each other for a long time. And actually, I think we got to know each other, even though we were at Texas A&M together, we actually got to know each other better just in the .NET community.
Yeah, that's right.
And you've been on the show and you've been doing software a long time. But just for the listeners who haven't heard you speak or getting to know you for the first time, what is it about programming in general that just kind of keeps you energized and keeps you coming back for more?
I think it's the ability to create, to build something. When I was younger, I used to like art a lot. I was never good with my hands. I was really terrible at construction, mechanics, all that kind of stuff, which my dad was really good at. And so I don't know if I just turned to it because that was what I had available to me or what, but there's something about programming that strikes a chord with artistry, but combined with like math and science that I had a knack for and really enjoy. So I think it's something along like some sort of mix or thread between those two things that keeps pulling me back into it. I've thought about trying to quit and become a farmer. I don't think that will ever actually happen. I'd probably be terrible at that too. But yeah, programming is just it's fun. It's always a new challenge all the time.
Yeah. Interesting. No matter how much the technology changes, I always keep coming back to realizing we're still figuring out how to get this amazing machine called the computer to do interesting things.
Absolutely.
So, well, I want to ask you about some things that you've been thinking about a lot, and you posted on your blog, and that is just under the umbrella of AI and how it's changing the development process, what it's good for, what we thought it might be good for, but we've come to learn that it's just flat out wrong. And I think everybody's in the industry is learning how to use it and apply it to your individual situation. So maybe just rewind, since Christmas, that time frame, because it seems like a lot has happened really just since Christmas. What seems to work really well, and what disappointments have you experienced also?
Yeah, that's a pretty loaded question. I think the things that have been working well is treating AI as a thought partner. That's where I've found some really great experiences. Getting it to quiz me, getting it to check some of my assumptions or asking questions about architectural direction in some cases, or asking whether I've been a lot of my recent experiments have been along the lines of evaluating whether things that we used to do back in the 90s and early 2000s are worth revisiting today. Along those lines, like hypermedia. I know it never really went away, but it's become like MCP servers and other things have kind of replaced it. There's a lot of different formalisms expressed in XML that just kind of got thrown away or were deemed too difficult. And it's been interesting to see that at least through my conversations with AI, it seems to think that there is some promise there. So I've been doing some experiments with some of that. The challenges I've been running into are the implementation side. So like figuring out how to brainstorm a solution, check different options, work through a plan to build something that's been working well. The implementation side has been a lot more fraught with peril. Building test cases, reviewing things at the other side have also actually proven out to be really well, especially security reviews. I think the last time I was on, I might have mentioned that I spent time in internal audit for a while. And so I've been able to kind of apply some like my old internal audit training that I've tried to forget back into building some agents to do that on my behalf. I'm just like, hey, this actually works pretty well. So they've been really good at checking things and helping me think through problem spaces and narrow down solutions. Over and over, I've been running into lots of challenges on the implementation side. Just been, that's probably a whole nother line of questions we could get into.
Yeah. Well, I do want to ask you about just your architectural thinking and strategy, but let's get super tactical for now. Because I think a lot of people, some people are still on the sidelines hearing all about, AI, everybody else, quote, is using AI and I'm not yet. So let's get really tactical. Exactly what tools do you find yourself drawn to these days?
I am primarily on the terminal. Previous job I was at got me fully into Vim as my primary editor. And so I've been working in the Windows terminal. I've got PSMux there. I've got Windows subsystem for Linux running Nix OS or Ubuntu in different environments, and using tmux a lot to kind of be able to spread out multiple terminal sessions within like one terminal screen, and then doing Claude Code and Copilot CLI as my primary tools. Along with those, I've been using a lot of the Claude models. Obviously, I've been pairing that with Codex and actually trying to use them against one another in many cases. And then
the tool
using
or just the model?
The model within the tool. So like using like Copilot CLI with Codex.
Okay.
Working on the same folder path as I'm working in Claude Code. So I'll have like one doing implementation and one doing an ongoing like file system watcher to like see like when something changes, is that a good change? What feedback do you have? Sometimes I wait until I push it up to GitHub, and then I'll use like the Copilot code reviewer in GitHub to review PRs that are coming in.
Yeah.
I've got some custom instructions to help get the Copilot reviewer to apply additional rule checks and things that I want beyond just the defaults. So things like that are kind of the primary tools.
Okay. So that's all, terminal-based prompting essentially, right? So you kind of moved away from the Copilot or Claude AI windows inside of an editor, inside of an IDE. Right?
And I still use those from time to time, mostly for like a lot of like using Claude Desktop or using VS Code. If I want to do something more visual, I've been starting to use Claude Design just a bit. I've only played with it a tad. So things like within the browser. Don Syme, and I can't remember who else is working in this at GitHub next. I've been doing some agentic workflows, and a lot of that stuff has been built into, I guess a lot of that you still use the terminal to create, but then you can visualize and see how they're running, when they're running, and things like that within the GitHub workflow and agentic workflow systems in GitHub itself.
All right.
I think I'm starting to go far afield here, but that's the general area.
This is good. I'm trying to be like really concrete because there's so many things that are said out there in the industry, and then people who haven't done anything yet are saying, "Oh, okay, I'm hearing this, but what exactly does that mean? What do I download? What do I use? How do I?" And so you mentioned the term agentic workflows. So let me just ask you the question: what is, like, give me examples of like what the heck is an agentic workflow and what makes it agentic?
Yeah, that's a great question. So the agentic workflows that GitHub has, this is probably more of an advertisement for them, but those are predefined descriptions. So they're basically markdown files that get computed, they get compiled into a YAML description that then is passed to a Copilot agent running inside of GitHub. This is essentially just a GitHub workflow, but it's calling out to Copilot to say, hey, look at this prompt, do something with respect to that prompt, and then take action. The one that I've been finding a lot of really great benefit from is the repo assist agentic workflow. There's at my current role, I'm primarily responsible for one project. This is within Quorum, but I'm helping out with like 3 other different repositories and projects. And there's no way I could do all this completely on my own. So I've deployed some of these workflows to be checking the state of the repository, making recommendations for different unit tests, documentation updates, rebasing open pull requests whenever certain other ones get merged. So it's basically doing a lot of the things that I used to have to go and like do lots of clicks and go back and do it the next one, click again, rebase, all those types of things. It's doing a lot of that automatically, but I'm not having to tell it exactly what to look for. It's basically like, here's some guidelines, and then the agent is determining based on those guidelines, what should I go do? What would be a helpful thing that probably isn't being taken care of by an active developer? Again, unit test coverage is like one of the ones that's been the most helpful. It's filling in gaps that we missed when we did a PR, when implementing something. It's looking at different kind of integration scenarios where we may have been working on 2 different modules, and it's like, oh, this looks like these are related. Let me add some test coverage around these, how these 2 work together. It's been really, really nice because it's kind of almost like a third thinking partner looking for some of these things. That's where the agentic part comes in. And they're, not deterministic. So sometimes they have been not as helpful as other times, and you just close the PR. But the signal has been quite strong. I haven't noticed as much a noise in some of the ones that those have been working on.
Yeah. And whether it's GitHub or another tool, it seems like there's so many scenarios where potentially, if you have a trigger, if you have something that happens, like if there's a new bug that was just reported in production and the work item just lands on the board and nobody's looked at it yet, well, regardless of who looks at it, the first thing that we have to do is gather information. Grab logs, grab telemetry, metrics, and relevant stuff from the environment that it was reported to, and gather it all together, because the first thing we need to do is to reproduce the bug. Seems like just that, if that could be automated, then that's a win, because somebody has to do it every single time.
That would be nice. I have not been brave enough to give most of my agents access to everything unless I have like hands-on keyboard control. So I've been doing a lot more of that from the terminal. And having access to tools like the Azure CLI, Azure Devops CLI, GitHub, all these different tools. Sometimes I worry that I've got too much access to things, but like I have definitely done that with agents from the terminal, but only when I have like strict control, and I've tried to put some pretty good guardrails on like what it's accessing when. Only do it when I ask. Those have been proving to be pretty good. And like you say, like it's really nice to have that automated to give it access so it can pull those things together for me, rather than me have to go and pull it all together myself. The danger I keep worrying about is giving it like within like an agentic workflow context. I don't want it going and hitting all those things and then just running up the bills because it's pinging too many things. It's doing too much data extraction from different services and things too frequently. I was helping another part of the organization do something like that from Salesforce. And we started with a GitHub workflow. And I think that's the end of the first day of running that every 5 minutes. They're like, we just ran up like $200 overage. Like this, so they used up all of their GitHub credits and then went $200 over within the first day, and didn't have like the full capacity that they needed to actually get a lot done. So there's definitely a lot of safeguards that need to be put in place before giving it too much access.
Well, I think that's a real issue that we have to struggle with. Is there's so many tools, and we could auto trigger a prompt, but like you said, every time a prompt is triggered on Copilot, for now, it's using one of those premium requests, and we've heard that in June the premium request model is going to go away, and it's going to be billed per token or per million tokens, just like the others, which invariably is going to make the price go up. We just don't understand how much. And so what have you seen from a practical standpoint about if you're going to do this, how much it costs just to get into that kind of game?
I don't know. Like right now, our guidelines have been, if you run out of tokens, let us know. We'll give you more. I think at least where we are right now, we're willing to pay that extra cost to see where we land. We've also started doing some investigation and running local models. Most of our computers don't run them well.
Yeah.
But we started looking at like alternatives to the cloud-hosted premium models. I've had some decent experience with things like Quen Coder, but only for like really small sorts of tasks. So it's we're still in the experimental phase, and so like I think it's because there's still low adoption in the use of some of these tools. I think they can still afford to pay higher costs per developer for the types of things we're doing. But once the adoption is being pushed pretty heavily, and I think once the adoption gets closer to 70, 80%, it's going to get really, really pricey, and we're going to have some better answers to some of these things.
Yeah. For the longest time, running production environments has been expensive, but it's worth it because it's tied to how the company makes money. And you say, okay, we're spending this much on hosting costs, and we're spending this much on maybe a warm standby or resiliency failover solution just to make sure we don't go down if something happens. And it's worth it. Why? Because maybe we're doing e-commerce and we make this much revenue per hour, or we're doing something else, and we can tie it back to a return on investment from running that. But then you pull back to, let's say, a developer test environment, and we say, no, that's just, we have to, okay, how little can we pay to get an environment where we can test a new build for a handful of people who are going to use that environment? And then it's like a fixed cost just to be able to do what's necessary. Seems like a lot of the scenarios that we're talking about is where the development team or product management needs to be the users, as opposed to our, the end customers who are revenue generating. And so it's the same thing. It's like, okay, we can't have elastic expense here. We got to have a budgetable expense.
Yeah, and I think there's another trade-off too, is everyone is expecting these things to make everything go a lot faster. And in many cases, I'm running like 12 sessions at one time, like 6 different tmux panes across like 2 to 3 different terminal tabs. And it's one, hard to keep in your head, but 2, I'm spending a lot of tokens when I'm doing that. It is moving things faster, but then some of those, if they're not well defined up front, they're coming back as like there's still some bugs or there's still some things to be fixed. It's sort of a garbage in, garbage out. The data needs to be very, very good and solid in order to get a good product. And then you can still get bad sessions. I think we're still very much in an experimental period here where there's going to be some extra cost to get into this game. For whatever reason, everyone seems to think it's worth it to do it now.
Yeah.
There's probably some balance that we still need to find in organizations to make sure we're actually doing the right balance of experimenting to some degree and like what areas are the highest profile. So you were asking earlier, like the ones where you're thinking through problem solving and applying some generating test cases, both of those seem to be really high value. Some of the other parts, implementation side, there's certainly some, especially when it's a smaller thing, like if you're doing like CRUD screens, easy peasy. Like the tools work really well for that. If you're doing something more complicated, you might be throwing several sessions away before you get a real good solution.
Yeah, that's certainly true. I do wonder. You mentioned the local AI. I remember when cloud came out, and we're all asking ourselves, okay, we can spin up any kind of computer in Azure, in AWS. We can, and we've all wrestled with okay, what should be there and what should be local. And there's cost is certainly one thing, but developer process is another thing. For example, if we end up with for the longest time with continuous integration, it's been a staple principle where you say, okay, you have a private build that you're able to run locally, and you got integration tests, unit tests, and other things. And then you've got the integration build that runs on a team server or on a build server somewhere. But for the private build, it needs to be able to run locally. You should be able to run that on an airplane. You should be able to send that computer to the moon, and you should be able to run that build. Why? Because it doesn't call out to the network expecting something else to be available. Everything is there. Well, if we end up in a place where the private part of our DevOps process has all these LLM calls, and every single one of these LLM calls is hosted by something, well, now we no longer have a private build. That comes to mind.
Yeah, I think that'll be a real problem, especially for tools that do rely on having agents running within them. One of the tools that I'm helping work on right now is like an agentic platform. So it's not technically running agents inside of it. It is like a whole platform for our products to be able to use and leverage. It's going to be using cloud LLMs, cloud-hosted LLMs initially. We'll see if we ever get to the point where we want to host some of those things locally to avoid some of those types of issues. Several of our customers have been fully on-prem, so this could get interesting as we want to start rolling out tools like this in an on-prem air-gapped setting, and there's always the possibility that they are already subscribed and have their own licenses to cloud-hosted LLMs that we can just plug in instead. But I think it'll be an interesting scenario to see how this all plays out. The nice thing is a lot of those self-hosted LLMs, the open source ones, are getting to be, and they're probably not as good as the flagship like Claude Opus and Codex and all those, but they're not too far behind. They're catching up quite a bit. The real question then is how big of a model is necessary. And for a lot of tasks, it seems like some of the smaller ones, actually, the heavily quantized ones, can do quite a bit and still do a decent job for the types of tasks you want to run in an application setting. Maybe not to do your coding for you as a coding assistant, but to do some of the agentic pieces within an application setting. The local LLMs may be sufficient. They're getting better, and they're getting smaller, and there's a lot of things on the horizon. I was talking about this with someone the other day. The hierarchical reasoning models, the tiny recursive models, the Microsoft's BitNet I haven't seen any progress on that in a while. That's the ternary model that they came out with. Those could dramatically shrink things to the degree that you could run it on like a Raspberry Pi or some sort of IoT infrastructure really easily at runtime. I think like the build part, like you still use cloud compute to build out the model, but then the runtime becomes something that's really tiny. I think as those things evolve and come out and enhance what's currently available over probably the course of this year or certainly into next year, we're probably going to continue to see some pretty significant shifts in what we think of as possible, what those environments look like. I think it's going to be an interesting ride for the next at least 18 months, probably, for some of these things.
Yeah. I'm just looking at the cost alone, and I mean, I think all of my engineers are probably up to $1,000 a month in just token, AI usage costs, and it's probably going to go up. And so I'm thinking, okay, well, if that's the reality, and it's at $12,000 per year, okay, what kind of GPU can I get for $12,000? And then, does it have a 3-year lifespan? Okay, well, then that cuts my average cost down to $333 per month amortized instead of $1,000 if it has a 3-year lifespan. Yesterday I was testing some things on an RTX 5090. I was testing the Gemma 4 model, the 31 billion. And if Google now is pushing out some pretty capable models, well, I know their play so that they can have something really good embedded with Android, because Apple's going to have one too. So they've got to compete on Android. Then, that really helps. That really helps the local one. And yeah, maybe we can't have like a 4-hour session to build an entire module, but okay. You were telling me before the show that a lot of those fail as well. I had those fail. And so will you tell me the story I think a lot of people have encountered where they get something going, they think, "Oh man, this is going to save me so much time. I did all this prep and now it's going to get something working." And then of course you let it go and then you come back and then disappointment.
Yeah. So you mentioned my blog posts. I had got posted like maybe 2 or 3 times fairly recently. My plan was to have by this point posted another like 6 to 8. I had articles planned out based on like in the schedule of what I was going to be doing in the Frank project that I've been working on. I added Open API, which I had been planning on doing for a long time. I've been working in the data star space. For those of you who don't know what that is, that's like similar to HTMX, but uses server-side events and some other things. Just some interesting areas that I thought were fun. And I had some really great success with, I think it was Claude. I think it was even like Sonnet 4 or 5 helped me build those. I don't think I was using Opus for those. And it wasn't quite a one shot, but I had really, like they got built out, very well defined, consider different trade-offs, and everything went well. That was probably into January. And then I thought, there's some other things that I really want to try out. And I wonder if MCP servers are kind of the state of the art for LLM, for tooling and tool calls and things like that. Well, my thought was, what if hypermedia actually is a better way to do this? And what if there's good ways to design or provide developers tools to build hypermedia applications that the kind of the full picture here is like, what if the LLM doesn't need to keep state? It can actually dump state constantly, because a hypermedia application in the traditional sense would be, it's considered stateless, but it's meant like the client doesn't need to keep state. You're giving it a stateful representation almost like every snapshot. So it does an action, it gets here's the new representation of the state. It could just be dumping its state constantly and get like, here's the next set of things that I'm allowed to do. So like in a game like tic-tac-toe, if I take a turn, the next screen I see says I can't do anything until, like, let's say we're playing, then you would get to take a turn. When you take your turn, now your screen says you can't do anything. Mine now says, oh, here's the remaining boxes that you can check. It's pretty straightforward, limited set of options versus an MCP server where it's like, here's a bunch of descriptions and here's a bunch of tools and you figure out what you need to do at any given time. That's a whole lot of background. There's a whole bunch of pieces into this, like theories and all these things I was trying to put together to make this work. Long story short, I started on this path of trying to take some like old formalisms from the late 90s, early 2000s and see like, can I build some tools? Can I get the LLM to build it correctly? Because I'm using these formalisms. Can I build it in such a way that it presents things and using these formalisms to restrict access? The LLM's like, this is exciting. I will be able to use this, give me a great feedback. They're like, these ideas are real solid, very sound, help me think through like how to best structure them. I got about a couple weeks in, and the plan had been structured in such a way that I didn't have a great early feedback. I could check little pieces, but I couldn't check the whole until I got basically towards the end. About a month in, I finally got to that point and nothing talked to each other. I was like, what the heck happened? And by this point, Opus 4.6 had come out. I had upgraded to like the Claude Max subscription, and I'm like just pouring tokens in. Mm-hmm. I discovered Git work trees, so I'm doing like lots of parallel implementation, just constantly keeping the machine fed. And get to the end and realize that like none of this is hooked up. So I start trying to plug the holes, make new plans, make new issues, iterate. And finally I get to the point where I'm like, this is actually missing significant portions of what it told me it had finished. And like I can go back and read test cases, start looking closer, and like the test cases are named a certain way, but then what they test isn't actually what they're doing. Mm-hmm. And so I start asking the robot or the LLM, like, what happened here? And it's like, oh, well, the sub agent silently deferred this bit of the requirements. I'm like, silently, you never did. So I started looking through the transcripts, looking through all these things, and like, lo and behold, it's basically just been like lying to me that it had done certain things, that it accomplished all the requirements. It was doing it in such a way that it was like hiding the fact that it didn't do certain things. And only through like going back and reviewing what it had actually done, looking through some of the logs and things, was I able to determine that it had like truly just hidden, decided on its own to hide requirements. I tried to start putting in guardrails to prevent it from doing so, and it was essentially continuing to find shortcuts. So I spent another month kind of working through all this stuff and finally realized, like, I think at this point, it's both leaning on the fact that it's built a bad base for everything else. It's continuing, like all of my rules and things that I'd started building up to try to prevent it from doing it were getting ignored. I was like, I probably have too many. It's like I've gotten to the point where now it's just picking and choosing what it wants to adhere to and silently disregarding rules that it doesn't care about. And so at this point, I'm like back to where I was like sometime in January and trying to start over again with a lot of things that I've learned, but I've spent a lot of money in the process to learn that. But it has helped at work where I've been able to kind of start shrinking my rules, find like really good guidelines. There was an article not long ago talking about the JPL Power of 10, the NASA, I think it was Professor Holzman had like 10 rules for that they used at NASA because they'd had these like long lists of rules that no one knew, people disregarded because it was too much to remember. And they found that having a more limited set was better and still comprehensive. It's like, here's like the guidelines that you need to always definitely adhere to. So I pulled that in. I pulled in some other stuff that Karpathy recently published. I think he had like four guidelines, and those have been transformative. It's once again asking me when it gets concerned about something. It's stopping where I want it to. Like I'm getting better results by reducing the rules, but also going a lot slower, checking things much more frequently. I think that prior success on some simpler things gave me a false confidence in the robot's confidence. And now I'm learning again, like I need to be a little bit more skeptical when I'm working with these tools.
So you mentioned since January, so this is your side project and you're just trying to keep an agent going, passively kind of on the side.
And I spent a lot of time planning this out. So I thought with the real solid, and part of this is going back like even into late last year, using SpecKit, using SpecKitty, a couple of different tools to help do spec-driven development. Those had proven to be really useful. A lot of what I've been using more recently is like some customizations on Claude's superpowers plugin, where it has like brainstorming and planning and some other things that it does that I found to be probably just as good. And it follows the same kind of principles. It's a simpler set of things. And it seemed to be working a little better than some of the other tools. But all of this just continues to be iterations of learning, of trying different things, running face first into a wall and then backing up, starting again. And I think initially I was really annoyed by a lot of this because I kept expecting like, well, the goal is speed. The goal is like these things should be able to do this stuff. I keep hearing from people, this is supposed to do it. And I keep finding that as many people continue to proclaim like these things work, when you really look at what they've got, they're probably being a little bit overly generous and into how well they work. It's definitely a mixed bag, and it depends on what you're doing, how you're doing it, and the level of quality that you're expecting coming out of these tools. I think it can definitely get there. It just takes it's the 80-20 rule always. Like you can get 80% of the way there really quickly. That last 20% is going to cost you quite a bit of extra time and detail and iteration and all those things. So a lot has changed, a lot has not.
Yeah. Well, the name doesn't help. The name, it's called artificial intelligence when really it should just be large language model. Hey, what can a large language model do? Well, it can do all these things, but given that we're calling it artificial intelligence, and then Anthropic, gave the name Claude. It's like, oh, Claude, it's your buddy. Yeah, it's like it's this guy that can do all kinds of stuff. See, it's a name. And then Copilot. It's like, man, your Copilot can fly the plane if you need to go to the bathroom. It's like, no, it can't. Right. And so it's like all these personifications to make us think that there's some actual intelligence, that there's some type of awareness of what's going on. There's some type of understanding of the task at hand. And there's none of that. It's just a stateless API call with like a fraction of what we have in our own brains.
Yeah. And it's literally predicting a next token. It's easy to forget that that's all it's doing. What's the next most likely token that's expected here? And when you think about that, it's pretty remarkable what it can do and what it's been able to achieve. But I was listening to another podcast recently where I think everybody was really surprised when they hit this point with the transformer architecture that is the most popular right now, that these things have been able to do what they can do. Like, I don't think anybody expected this level of output, and it's pretty good. The other thing to remember is they're trained on us.
Yep.
So a lot of the like shortcuts and other things, it's like it's reflecting human failures because it's reflecting how we have communicated, what we have written. This is a little weird. It's like somewhat a reflection of human nature coming back out through this like next word prediction. It's attempting to reflect a realistic picture, which I think is why it's worked really well as a thought partner, because you can talk to it especially if you're not trying to nail down an exact precise thing. If you're doing probabilities or doing trade-offs or comparisons, it seems like you get much better results. And I think a lot of that's because we're really good in like fuzzy things and not being too prescriptive. And if you let it be too prescriptive or overconfident, it will be overconfident, much like many humans like to be overconfident. And much like my statement just then was probably a little too overconfident. But
I think probably everybody who's been reading stories has heard of the Pocket OS deleting the production database episode. Because the tool calls was running into context that had the capability to call that API that could delete the entire data volume. And that's, I mean, I've had plenty of conversations about security token segregation. It's like, okay, for this task, it should only ever read. So let's make sure it's using a token that can only read. Now, this other task, okay, it can write a few things. And it's almost like if we let it run under the security context of a certain set of operations with LLM tool calling, we should expect at certain points every single one of those variations is going to be called, and we need to be okay with it. But even the guardrails, you mentioned, guardrails and rules and all that stuff. It's still just English. And in the Pocket OS situation, they had a quote guardrail that said, "Do not do any destructive operations." Well, that we have to assume that this technology, the language model transformer technology, has an awareness of what destructive means. And there's no understanding of the concept of destructive.
Yep.
And so it's like, we have an awareness. I was looking at an estimate, even with the 1 million token context window. It's like this tiny little sliver. Our brains, if you translate it into tokens, I saw an estimate that you would need several 100 million token context window to actually be equivalent to the size of neural network that we use to operate. Because I don't know about you, but I'm remembering a time 15, 17 years ago in my career when I was involved with something that actually did cause problems for a production database. And I remember the details about it and the wounds. And so every time that I'm involved in doing something, guess what? My brain and my neurons, it's zooming back to that memory of the things that led up to that, and that's coloring my actions in the present day to make sure, okay, we need to make sure that that type of thing is not possible.
Yeah, I think all of us have those kinds of stories. I have definitely, thankfully, outside of business hours, dropped production databases. And I'd just done a backup, so I was meant to drop the staging. So it's easy to like fix the problem, but it is funny. The destructive seems like it should be easily translated, right? And maybe it's not. I have a literal. Well, this has been fixed recently, but I had a literal command in mind. I've been using work trees for everything because it lets me do things in parallel. I had a literal command: never commit to main. You know how many times it has to like remind itself not to commit to main?
How
It's
many?
not 100%. but it's surprisingly high, given that that's like one of the top instructions that I give it all the time. Like, never commit to main. Oh, I shouldn't commit to main. Let me try this again over on a. Like, really? Like, why is this so hard? But it's, as you mentioned, it's artificial intelligence. It's not an actual intelligence. It doesn't actually have.
Yeah.
It's got whatever's in its context whenever it's running and chooses to reflect on.
Yeah. So read another article, gave a good analogy I liked, where it talked about a book, reasoning about a 500-page book. If you and I, both read at some point in our life a 500-page book, we don't have to have the entirety of the text in our brains to be able to kind of relate some stories or talk about the gist of that book and what it was about. But a large language model has to have the entire text of the book in order to do any kind of reasoning about it. And so that's a big difference in capability right there.
Yeah.
Even if scientifically the technology is meant to try to simulate the type of neural network that we observe, our brains having, just from a structure perspective. All right. So now that we've dogged on AI, oh yeah, and this is all the time it screws up. Let's get back to, okay, going forward. Sure, there's the experimenting of, can I get it to do this? Can I get it to do that? But what are the scenarios where you and your team doing it every day and it's pretty much proven and there's no guesswork, and listeners out there should, if they're not already, they should probably start adopting it for some set of scenarios.
Yeah, my definite go-tos are doing pull request reviews. I usually go through at least a few rounds of either getting Copilot to review within GitHub itself, or running Claude or Copilot with one of the other LLMs to do the review and post the review. It has allowed us, well, there's that, and then there's another piece. A lot of the problems that we've been seeing is that people are now posting much larger pull requests. So the number of lines has grown, in part because like spec-driven development and other tools produce a lot of text artifacts, documentation, which is really good because it gives you a sense of a history of what's been changing, why were these decisions made. It's really good things to capture. Problem is now you've got like a 12,000 line pull request when like the actual implementation might be 20 to 40 lines. You got to if it's human reviewing it, you've got to go through a ton of stuff. Maybe you care or don't care about the documentation piece, but it's nice to get like the LLM to kind of do at least a quick review to find, and in particular things like security. It's like using the Holzman 10 laws type of thing. It's very heavily leaning on things about like security, protection, safety, things like that. Using some of the tools to put those lenses on it and then give you a summary of like, here's some areas that have some potential problems. Those are some of the areas that I've struggled with in the past. Like I won't necessarily always immediately see a potential bug or a null reference or something like that. If there's not a test case for it, sometimes I forget to think about, is there a test case for that scenario or not? And the tools have been really helpful at finding those holes and gaps and things. So I'd say that's one. The second one would be test coverage. Tests are expensive to write as a developer because you have to think about test cases. One thing I've been finding to be really, really helpful is the LLMs are really good at finding properties. So you can do property-based testing where it's doing the generator. It can write the generator, which are really hard to write by hand, or at least I've found it to be really hard to write by hand. But it can generate the generator, and then you can run the generator, right? Test around the generator to see like what's it producing? Is it producing the results I want? Then you can use property-based tests, which are fantastic for covering not just the things that you're thinking about, either a happy path or failure path, but like edge cases that you may not have thought about at all. So it's helpful for exploring. That's improved our test coverage tremendously and really helped us feel a lot more confident about what we're releasing. Those are probably the two biggest areas. The third one would be using it to explore the design space, architecture space before you commit to a design. So maybe you have some preconceived ideas, or you're like, this is how we've always done it. I'm just going to keep doing it that way. Pause and think, like, what other options are available to me? Why should I maybe consider a pivot to something different? How big of an impact is that going to be? how much cost is that going to, affect? If we decide like, oh, this actually is a much better architecture, is this something I can do right away? Is this something I need to start planning for over a period of time?
Mm-hmm.
The tools are really good at helping you think through those things. And in many cases, I think because of that, and I guess I want to call it an instinct, but again, this is a next token predictor, so instinct is probably the wrong word. But because they like to defer and iterate over doing these like massive one-shot type things, they're really good at helping you think through how to break something up. Another use of that is when you do have one of these very large pull requests. I had one just recently that was like 15,000 lines in a change request. It started like, it looked like it was going to be pretty small, and it kept adding things and adding things. And I kept realizing, oh, there's another gap. I can't release this until I get that done. So I had this 15,000 line pull request. I had created a skill to use with Claude to use when I'm doing planning called decompose. And the idea was like decompose this into a series of related things.
Yeah.
Identify the correct dependencies, figure out the things I can do that like pave the way for the next one. Then do that pave the way. So anyway, I took that large pull request, ran it through the same skill, and it actually broke it into 5 different separate pull requests that are much smaller, much easier to validate. The first one was like just a refactor of what was there that provided the exact same implementation, but in a new way that allows for the expansion of what I needed to build on top of it. And the tools was fantastic in helping me figure that out. It'd be very difficult to do that on my own. I probably would have, in my own human desire for laziness, maybe tried to break it into 2. It stretched 3. To do 5 was like, I didn't even think about the extra 2 separations that it came up with and helped me find. And it did recommend like, here's like these 2 are kind of small, so you could actually make it into 4. And I'm like, no, 5's fine. It helps me validate each step. Those kinds of things I think are very useful. The very much more practical, definitely the code review and testing. Those are things we already need to be doing, already have to do, and they're much better, I think, because of our tendency to just kind of rubber stamp the pull request, or I'll do the minimal coverage for testing that I need to do because I got this other stuff coming down I'm being pressed on by my boss or my project lead. The other part is more, I think, really almost the area where it can really help accelerate your own thinking, expand the possibilities of what you can evaluate as solutions, and really help you grow and shape a better solution. Again, maybe not immediately. I think that the tendency is to think this is going to do something quickly. And if you step back and think about it as I don't have to necessarily move faster. If I move better with greater care, overall, the whole thing will move faster. It's similar to your book that you published. Like if you do it well, the whole thing moves a lot faster and continues to make everything continue to run fast because you're taking good care and good steps and moving things well, not just going for the fastest thing you can possibly do and then painting yourself into a corner.
Yeah, eliminating rework. Yeah, for sure. Well, Ryan, thanks so much for coming back on the show and visiting with me again. This was fun.
Yeah, it was. Thanks, Jeffrey, for having me. I appreciate it.
Oh, my pleasure indeed. And until next time, dear listener, keep shipping.
You've been listening to the AI Devops podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.